Welcome back. Welcome back to MPB Learning with me, Ms. Killen. We are still in our Unit 5, Linear Inequalities, Equations, and Functions, and today we're looking at Lesson 8, Finding Systems of Equations Using Graphing and Substitution. We're looking at standards A, CED 3, and A-REI 6 and 11. I can explain why points are a solution set to a system using substitution and working on a graph. So let's go ahead and dive into this. It says, when presented with a system, we can substitute in one equation with parts of the other equation to solve for a variable. Now, when we do this, we need to make sure that we are looking at both equations. We need to make sure that we are seeing what one is, what different variables it has, what different coefficients it has, and then we need to look at the other one for the same elements of it. We need to make sure that we see what's going on in both of them so we can see how we can put them together. So let's look at this. We've got some different steps that we can use. First thing I want to do, in one equation, I'm going to isolate a variable. So let's look at this first over here. I'm going to isolate my x. That means I'm going to get my x by itself. To do that, I'm going to subtract my y on both sides. So I know exactly, I know literally what my x equals. X equals 5 minus y. So then it says, now that I know what my x equals, in the second equation, substitute in where you see x for that 5 minus y. So let's go ahead and do that and see what it looks like. So 2 times 5 minus y equals 4. And same thing that we've been doing ever since we started equations, I'm going to distribute 10 minus 2y minus y equals 4. Always wanting to get our like terms together. 10 minus 3y equals 4. I need to get that y by itself, so I'm going to subtract 10 on both sides. Negative 3y equals a negative 6. Divide by negative 3, and my y equals a positive 2. Now that I know what my y equals, exactly equals 2, I can plug it back into my first equation and solve for that x. So let's see. If x plus 2 equals 5, isolating, my x equals 3, my y equals 2, and that is how we use substitution to solve for x and y. Now, if I plug this into Desmos or in my calculator, they would cross at exactly 3, 2. So this is my solution set using substitution. Or I could go to Desmos in my calculator and find my solution set at also 3, 2. So now I've got another way to find these solution sets. So let's look at some more. All right. When presented with the system, we can substitute in these equations, and that's what we did. Now that we found out exactly what y equaled, we plugged it into the first one like we did over here, and we found out what our x variable was. So make sure once you find out what one of your variables are, you go back and you plug it in to find out what that original variable is. All right. Now let's plug these two equations into Desmos, like I said, and see if they intersect at these coordinates. So we're going to pull up Desmos, and let's put these in. So my first one was x plus y equals 5. My second one, 2x minus y equals 4. So if we did our math right, they should intersect at 3, 2. And they do. They intersect at exactly 3, 2. All right, let's try another one. But first, before we do this other one, we need to make sure that we're remembering our steps. In one of our equations, we're going to isolate one of our variables. Once we literally figure out what it equals, we're going to plug that expression into our second one and find what that second equation exactly equals. Once that I find exactly what it equals, I go back and I find for that first variable in that first equation. Those are our steps. We need to make sure that we have those in our notes page. We're going to want to make sure that we are checking off each step as we go. So now that we've got our steps, let's go ahead and use these steps in this problem. I've got a system of equations. 2x minus y equals negative 2. X minus y equals 6. So first I want to use our steps, then I want us to check it in Desmos. So I'm going to look here at this one. I'm just going to choose this one just because. And I'm going to solve for my x. So I'm going to indicate right here, this is what I'm solving for. You do not have to put that dot. The reason I do is to keep myself on track. That's the only reason I put that dot there. So I'm going to add y to both sides. And x literally equals 6 plus y. Now that I know literally what x equals, I can bring this over here, and everywhere I see x, I can plug in that 6 plus y. So then let's solve this. 2 times 6 plus y minus y equals a negative 2. I'm going to distribute 12 plus 2y minus y equals a negative 2. Putting my like terms together, 12 plus y equals negative 2. I am going to subtract 12 on both sides. So my y equals negative 14. So I know exactly what y equals. Now, listen to some words that I'm using. Literal, exactly. When I have it literal, I have what the expression is. When I know exactly what it is, it's exactly negative 14. So now that I know it's exactly 14, I can take this y amount and plug it into my original equation and solve for what x is. So let's do that. X minus a negative 14 equals 6. We have learned that when I subtract a negative, it's just like adding. So then I'm going to subtract 14 on both sides, and x equals negative 8. So my coordinate or my ordered pair would be negative 8, comma, negative 14 would be my solution set for this system of equations. Now, you may be sitting there thinking, Ms. Killen, I didn't exactly get those. Maybe I didn't do this, or maybe my sign was wrong. So we can always go where to check. You're right, Desmos. So let's go to our Desmos and see if where my two lines cross is at the same place. So let's put these in. I have 2x minus y equals negative 2. And then I have x minus y equals 6. Now remember, we got negative 8, negative 14. So where these two cross is negative 8, negative 14. We found the exact solution set. The exact. Let's try a word problem. Melvin's Movie Theater sold a total of 150 tickets, with adult tickets costing $10 and the student tickets costing $5. If the total revenue from ticket sales was $1,000, how many adult tickets and student tickets were sold? Now, before we start, let's remember something. Number plus number equals number. Money plus money equals money. Good job. So let's look and get our numbers right. I know that my adult tickets plus my student tickets equals 150. And then my adult tickets are $10. my student tickets are $5, and my total revenue, or the total amount of money that we earned or we got, was $1,000. Now, we could substitute, meaning I could find out literally what A and S equaled and then plug it in, or we can use our calculator, or we can use Desmos. I'm just going to use Desmos. So let's plug this in. I cannot use A and S, so I'm going to use X for adults. I'm going to use Y for students. So I've got X plus Y equals 150. And then I have 10X plus 5Y equals 1,000. Now, when I just see my Desmos, I don't see any of my lines, so I'm going to have to press that minus sign and find out where they cross. They cross where X is 50 and Y is 100. X is 50 and Y is 100. So let's go back. We said that we were saying X was our adult, Y was students. Well, at our coordinates, 50, 100, so that means we sold 50 adult tickets and we sold 100 student tickets. All right, let's do some practice. Leslie worked 8 hours with Gary and he worked 10 hours. Their combined pay was $80. When Leslie worked 9 hours and Gary worked 5, their combined pay was $65. Find the hourly rate pay for each person. Check with Desmos. You must know how to interpret the coordinates and what they mean in the context of the scenario. So let's go ahead and write the equation that we're going to use. Because even though we know how to substitute, even though we know how to use Desmos, if we can't write our equation from the context of our passage, then we're going to have a problem. So let's go ahead and write. Let's see. I've got Leslie, and I've got Gary, and I'm going to assign Leslie my X value and Gary my Y. So it says first, when Leslie worked 8 hours and Gary worked 10 hours, their money was $80. Then it said when Leslie worked 9 hours and Gary worked 5 hours, their money was $65. Now, we've not had a problem where both were money, but that's okay. Sometimes you'll have one where you'll have numbers and money, sometimes you'll have two numbers, and sometimes you'll have money and money. So you want to make sure that you can interpret what the passage is telling you. So let's see. Now that we've got our two equations, let's see if we can pull this on Desmos. So I'm going to put my two equations in. I've got 8x plus 10y equals 80, which was our first. And our second was 9x plus 5y equals 65. I see 5, 4 is my intersection. 5, 4. So let's take that and go back and see what the context of this passage means when I have a solution set of 5, 4. So I'm going to put my solution set right here so I can go ahead and see what it is. Now, it says that Leslie was my X value and Gary is my Y value. That means that Leslie makes what? $5 an hour. And that also means that Gary makes what? $4 an hour. Being able to interpret what our solution set means to our passage is going to go a long way, because one of your options could have been 5, 4 or 4, 5. And if you do not understand what they mean to interpret for the context of the passage, then you're not going to know which one is what. So we've got to make sure that we're interpreting these numbers correctly. Okay, mine has 24 dimes and quarters worth $3.60. How many quarters does she have? Remember what we know about money. Write your equations and check with Desmos. Now go ahead and pause the video. You and your table partner work, or you work on your notes page, and then come back to me and let's see what we got. All right, so when I read through this passage, this is what I got as my equations. Double check my work. I have my dimes and my quarters. I know my dimes are 10 cents, and I know that my quarters are 25 cents. So I'm going to say that my dimes are my X values and my quarters are my Y values. Now it says that my dimes plus my quarters equal 24 coins. Then it says that my dimes amount plus my quarters amount equal $3.60. Now, I could solve for X or Y and plug that into my bottom equation. No problem. But let's go ahead and pull Desmos and see what it says. So I'm going to put my two equations in. X plus Y equals 24. Then I'm going to put 0.10x plus 0.25y equals $3.60. And let's see where they are going to intersect. 16,8. 16,8. So let's go back and see what that means. My coordinate is 16,8. So in this context, my dimes are X, so I have 16 dimes, and my Y's are quarters, so I have 8 quarters. That's how we take our solution set and make sure that we can interpret what it means in our passage. Okay, that's what it means in our passage. 16 dimes, 8 quarters. So let's look at some more. We're going to master this. The talent show committee sold a total of 530 tickets in advance. Student tickets cost $3 and adult tickets cost $4. If the total receipts were $1,740, how many of each ticket were sold? Go ahead, pause this video, write your equations, work your equations, find out what your solution set is and what it means in this context, and come back to me. All right, so this is what I got for my equation. I'm going to say I have adult tickets and I have student tickets. My adults are going to be X and my students are going to be Y. I know that my adult tickets are $4. My student tickets are $3. So I'm going to write an equation. I have my X plus my Y, my adult plus my student tickets equal 530. Then I have 4 per adult plus 3 per student equals 1740. I'm going to solve this by substitution. So let's look. I'm going to solve for my Y. So X plus Y equals 530. I'm going to subtract X on both sides. So Y literally equals 530 minus X. Now, everywhere in my second equation I see a Y. This is what I'm going to plug in. So let's go ahead. 4X plus 3 times 530 minus X equals 1740. I'm going to distribute 4x plus 530 times 3 is 1590 minus 3x equals 1740. You always, always, always make sure that we put like terms together. So 4x minus 3x is x. I'm going to get my numbers together. So x equals, I have my calculator, 1740 minus 1590 equals 150. And now I'm going to take exactly what this equals and plug it in up here. So 150 plus y equals 530. I'm going to subtract 150. Y equals, so I'm going to take that 530 and subtract that 150 from it, and I get 380. So for me to be able to talk true context of 150, 380, I have 150 adult tickets and I have 380 student tickets. Making sure I am seeing fully what each number represents in this passage. I always want to make sure I know what it equals in the passage. Okay, let's look at one more. Kevin has a maximum of $80 that he can spend on books. He wants to buy a combination of sci-fi books that cost $12 each and poetry books that cost $8 each. To help Kevin, let's help him create a graph with a number of sci-fi books on the x-axis and a number of poetry books on the y-axis. If Kevin wants to buy 9 books, what might the combination of both genres be? All right, so go ahead and pause it, work it, graph it, and let's see what we got, and then come back to me. All right, so let's see what we've got. I've got my equations, you've got your equations. I'm going to plug mine on Desmos since I can't draw straight lines, and let's see what we got. So my first equation that I came up with was x plus y equals 9. So poetry plus sci-fi, or sci-fi plus poetry equals my 9 books. Then I got 12x plus 8y equals $80. So where they cross is my solution. And I have them crossing at 2, 7. So now that I have their intersection at 2, 7, let's go back and see the context. 2, 7. So I said that I had my sci-fi and I had my poetry. I let my sci-fi be my x and my poetry be my y. So that means I get 2 sci-fi books and I can get 7 poetry books. That is how I interpret my numbers in my passage. Let's not forget the steps that we've learned to substitute literal values of variables to make sure that we find the missing variables. We're using Desmos to check our work after we create these equations, and then we're reading our word problems for useful information to build our equations with. I'm so glad that you came back to learn with us here at MPB. I'm Ms. Killen, and thank you.